Okay. So, hi everyone. Thank you very much for being here. So, I don't really know what this talk is about because I was asked couple of months ago to do a kind of like a design talk about different paradigms, like functional versus procedural versus something else, object-oriented. And I really wanted to do this at first, but then I was researching this topic, and I came across something. We need an inspiration quote, so. And I came across something that it explained something that I personally experienced when learning something. I'll get into this very soon. And in that moment, it became clear to me that I didn't really just want to do a technical talk, just showing you stuff. I wanted to maybe try and explain how to arrive at those conclusions and whether or not different paradigms really do affect the way that we think. So if you've seen my previous talk on the subject of functional programming, don't worry, I'm not going to talk about monads in this talk. But I do want to kind of explain something, where does my knowledge come from and how my views and opinions were changed and what caused them to change and what happened because of that. All right? So this talk is about paradigms. Now, I went and searched I did all kinds of research about what is a paradigm, what are programming paradigms. And there's this guy called Peter Van Rooij, who is a professor of computer science. He wrote a book studying a bunch of different languages and paradigms. And he defines a paradigm to be this approach of programming, blah, blah, blah. But he did a research on, he wrote a paper on analyzing different programming paradigms and how they occur, what they look like. And how many programming paradigms do you think there are? Just give me a number. 12, 15. How many different programming paradigms do you think exist today? There are over 2,000 programming languages out there, but how many paradigms? 160. All right. So the answer to this, at least at the time the paper was written, is about 37. So he did this. There's a link. You can read the papers. It's not very long. So he did this classifications of. Oh, come on. He did this classification of different programming paradigms. Where do they come from? How did he arrive to this conclusion to name them? Didn't just take a bunch of them and decided to put them into columns. He studied history, studied the relationship. There's no really need to look deeply into this chart. But the point is there are quite a lot of them, and so I couldn't possibly do I couldn't possibly do a good enough job to present you with an unbiased view of a comparison between maybe the most prominent paradigms, because there are people who are much more qualified than me to do that. But I do want to talk about this notion of learning, of being exposed to different ideas. And this book, how many of you read this book, or at least heard of this book? So this is one of those books that is recommended together with Clean Code and stuff. It's written by the Andy Hunt, and this other guy, their name is the Pragmatic Programmers, and it's a really good read that I highly recommend you reading eventually. But even at the very beginning, it suggests you to learn a new programming language every year, to try and do that. Now the question is, how many people actually do that? How many of you have learned a new programming language this year? Almost none. Almost there's very few people, and there's a reason for that. We don't really most of the time we're content. We're good with what we have. Before I came to Wix, I come from .NET. I was developing C# for a very long time, and I worked in a special kind of specialized field developing plugins for Visual Studio, which is the IDE. So this required me to kind of have this control over the language. It requires me to, the product that we were building is debugging visualization extensions on top of what you normally get. So this required to analyze, to take the user source code, the source code that was written in the IDE, and to analyze it. Now to do this, you used tools that you get with a compiler. And this is just a tiny bit of C#, but you know, this can be Java or anything else. And as far as the compiler is concerned, the compiler doesn't see this this text. It sees it as this tree, as this abstract syntax tree, which is broken into a class. Every kind of single element in this little bit of code is defined in this element. There's a node that represents it. And has associated data with it. Actually, it more looks like this because every single thing, every single character in the text is represented by this tree, and especially white spaces and everything. So actually, the C# compiler doesn't care. It calls the white space and the braces trivia because it's just trivial. It's not interesting code. This is why there's no point arguing tabs versus spaces, because as far as the compiler is concerned, it's meaningless. But the point is, when you have this control over a language, when you know the language so good that you can reason about it, you can modify it, you can analyze it, you know all the corner cases and the implementation details of a language, which I had to know. I never seen any reason to look at other languages. I had friends that told me, hey, look, there's this new language called F#. Well, not new, but there's in the Microsoft world, there's a functional language called F#, and it doesn't have any nulls, and it's much more concise. It doesn't have these public modifiers, and it's much shorter, it's much denser. And my first reaction was, instead of saying, okay, that sounds cool, like you have like pattern matching, that sounds really nice. My first reaction was, well, so what? Okay, you don't have nulls. I don't really care. I have tools. I have spent a lot of my time into these tools and spend money buying these productivity tools that give me all of this, solve all of these problems for me, right? So I can generate null checks and I can generate all the boilerplate with a click of a button. That's not really a good enough reason for me to learn a new language, because I can do everything in my current language. Why would I possibly learn something? And I thought about this. I thought about this for a very long time as to why did I have this worldview? Why was this my default? And I came to this conclusion, now, bear with me, that the world as we know, most of us, most programming languages that we have experienced are basically this. This is a main function of Java. This can be C#, Pascal, whatever. Almost all of the programming languages that we know, our programs live and die between those two braces. This is kind of the entry point to the program. Everything that happens, everything that the program will do, happens between those two braces. All the universe that our program interacts with exists here. Okay? This means that by the very definition, by the way, our program needs to return an exit code, whether or not it succeeded or not. And everything else is kind of by definition, because it's a void, it's kind of like a side effect. Everything else that happens is sort of like a side effect that our program does. The point is here that just those two braces imply that all the work will be done here before we get to this point. This means that everything that we know today, every school of thought, every book, every design pattern, every practice that is built on how to manage the universe between those two braces. We initialize a bunch of stuff right here in the entry point, and we need to pass it along to the inside to collaborators or whatnot. And we do this in this componentized way, and there's a lot of knowledge, like years of knowledge, how to do this properly in almost any language, right? And for me, oh, this is impossible. For me, this was, can you hear me, by the way, without this thing? Do I need it? No, okay. Sorry about that. Oh, I'm going to put this here. Like I said, to me, this was the kind of the ultimate truth, right? Every language that you used, probably from the start, this is what you knew, right? And for me, this was the foundation on which all the software is built. And it was like this until this guy ruined it for me. Now this is Runar. He is the co-author of the Red Book of Scala, the Functional Programming in Scala book, which is a terrible book for beginners if you want to learn Scala, because it's not a book about Scala, it's a book about functional programming, which has happened to be written in Scala. He gave this talk in 2013 called Purely Functional I/O in Scala, and he managed to sneak in some Haskell in there, the bastard. So he started talking about Scala, and suddenly he said, oh, and by the way, in Haskell, it's done like this. Now, until that moment, Haskell was this language that I dismissed as irrelevant to me. I didn't need this. Like, why would I ever bother learning this academic whatever nonsense? I don't really need to learn this language. And so I said, Haskell, wait a minute, why, what? But then I'm not going to bore you with the details. But the point is, this Runar guy explained that in Haskell, it just works differently in such a way that instead of doing the work inside of your main, between those two braces, what you instead do is you kind of declaratively describe what you want your program to have done. And then it will be returned out of main. And the Haskell runtime will figure it out. And exactly what you describe will happen. There will be no other possible things, no side effects to this, because it's a purely functional language. The point is that the work is not done inside the main, it is done on the outside. So this just flips everything on its head, sort of. And what happened, I thought about this a long time. What happened to me was I had a bug. In my mind, this conflicted. This notion, this model conflicted with what I knew. I mean, I thought that every single language is just different. The difference is the syntax, right? They all compile to the same thing. They all work the same thing. You have dependencies. You have interaction with the external world. You manage them. You put them in containers. You put them in constructor parameters. You pass them around. You TDD them. And that's it. It doesn't really matter what language you use for this. But Haskell does this thing where it doesn't do the work inside the main. It does it outside. So I had a conflict of something that I knew for a fact that was true. And here somebody presented me with this idea that it's just not done this way. It's done differently. And it took me a long time, struggle to understand this. And it took me a couple of more rewatches until one day. One day I had the there is no spoon moment. It just clicked. I figured it out. And the second it happened to me, it was just like everything clicked into place. I don't have a good explanation for this, but I suddenly understood. I didn't understand Haskell, but I understood the idea of Haskell, the idea of why would you do this in this way, in this purely functional way. And I suddenly understood also why is everybody trying to replicate it in every language. Like why has Scala people put in Scala Z and all these functional libraries, because of the benefits this gives you. I'm not going to go into the details of that. So my whole point is that I had these two conflicting ideas until suddenly I agreed with one of them and I started seeing it. And actually I now don't really see like the old model, the model which I knew kind of makes less sense to me. And it was all fine until I started researching material for this talk, and I realized that this has a name. There's this textbook definition which describes this thing that I've experienced. And this is called a paradigm shift. This is the actual definition of this phenomenon. Now, the term paradigm shift comes from a guy whose name is Thomas Kuhn. He wrote a book 50 years ago that's called The Science of the Structure of Scientific Revolution, where it explains like the history. He was a PhD professor. He was a physics professor who also studied the history of science. And this book, I haven't read all of it. I read the abridged version. But he describes this idea where often science revolution, scientific discoveries are described as linear. Like Edison discovered electricity and somebody else described magnetism, and there was a process. And it's not really a linear, it never is. It's not really a linear progression. It is a cycle. So the cycle, he describes it as you have an understanding, you have people trying different things, and you have an established model of interacting with the world, the way to understand the world. And at some point, this model begins to change. People started practicing new things, and they find anomalies. Okay, so sometimes people find anomalies that just don't fit with the model, and they continue to experiment. Different people try to come up with solutions and reasons for this anomaly. And when that happens, when that anomaly is accepted to the consensus, to the worldview, it creates a crisis. Like something is wrong, something just in our model doesn't work. And when that happens, eventually this comes to this revolution, and which is in fact, Kuhn uses the word paradigm instead of model. Kuhn uses the word paradigm to describe it, and in his case it's fine because it's not a buzzword yet. He actually came up with it to describe this phenomenon, so he's allowed to use it. So the idea is that a paradigm shift is something that happens when you have an anomaly which doesn't fit the worldview, and it creates a crisis, and this crisis drives more ideas, more solutions until they become accepted. And once they are accepted, you have no choice but to flip your worldview. And so this is the quote which kind of seals this idea, is that when you reject one paradigm and you have no choice but to accept another in its place. I don't have the picture, but he gives this as an example. He gives this you know, this optical illusion of a duck and a bunny and a rabbit, and depending on how you look at it, you see either the duck or the rabbit. So this is an idea of a paradigm shift. Like, depends on how you look at how you interpret the same data, you can arrive at different conclusions. So to me, this was kind of this was a revelation. It resonated with me because it explained that I've experienced something that it took me a long time to understand. I struggled to understand it, but when I did, and it made sense to me, so it helped me to understand everything. This became my worldview. My paradigm shifted, and this became my worldview. I can suddenly understand it. And as a side effect, no pun intended, of this, this kind of removed, for the longest time, I thought, like, I realized that what I knew is just the tip of the iceberg. I thought I knew my place in the world. I knew software, right? But it made me realize just how very little I knew in actuality. There's this entire new world which was unfamiliar to me. And this realization helped me to kind of remove this barrier that I had from trying to learn new languages or trying to experiment with new things. Where previously I just dismissed them as something irrelevant, I suddenly gained interest in things that I never had interest before. And I'm going to show you a couple of these things. So we're not going to see any code. I purposely named this talk Beyond Syntax because I don't want anyone to focus on code. I just want you to focus on some ideas that other languages, other paradigms give us that we are just not used to, really. And the first one is Clojure. Now, Clojure is a language that all I knew about Clojure is that it was a kind of Lisp. I love XKCD, in case you haven't noticed. All I knew about Clojure, that it was a sort of a Lisp, which means it just has a lot of parentheses in it. That's all I knew about Clojure. But during the last hackathon in Wix, I decided Avishai wanted to do something, and we decided to do something together in Clojure. Now, I haven't used Clojure before, so I said, what the hell? Let's try this. And first of all, I must say that once you install the environment, we use the IntelliJ plugin. Once you install the environment, the parentheses thing is just really, it goes away within the first 5 minutes. First of all, the editor will not let you enter rogue parentheses. Like, you know, when you type in your code and you type an open parenthesis and everything goes red because the compiler is trying to figure out what just happened, this almost doesn't happen in Clojure because it will not let you enter mismatched parentheses. So that problem is solved. And another thing is, it actually has a funny name. It's called barfing. I don't know why, but it lets you, like, if you want to increase the scope and encompass more things in the parentheses, it's called barf. So it's like a first-class feature of the language. So that's the mechanics of using a language like Clojure is not really a problem. So what is Clojure? It was invented by this guy called Rich Hickey. It is a dynamic functional language. It's a dialect of Lisp. It runs on the JVM. It's completely interoperable with all the JVM ecosystem. And it was designed by concurrency. I'm gonna talk about that in a second. But first of all, a dynamic language. Now, I personally never used something that, like, I am allergic to dynamic languages because, you know, I have a compiler. Why would I use a dynamic language? But One of the benefits of using a dynamic language, and this is a screenshot, thank you for the screenshot. One of the things that you do when you use, don't look at this side. This is just a bunch of this is just a bunch of integration tests that we had to run, because when you have a dynamic language, you don't have types, you need to do a lot of integration tests. Now our system was like a image server which display banner ads because that's a problem that needs solving, apparently. So what we did is we used Redis as this backend, as this key value store to store the actual image data and retrieve them by URLs. And so we had to write a lot of tests for this, lot of like integration tests that spun an actual Redis instance, stored some data, retrieved that data. It was fun. Take a look at this. When I ran the test, it ran in 0.2 seconds. I mean, I took an animation yesterday. I hope you can see this. I'm pressing rerun a couple of times here. This thing just runs. These are integration tests that talk to actual Redis, and they finish in under 3 seconds, in under 0.3 seconds. In my day-to-day job, I'm waiting, like I press the run tests button, and then my IntelliJ goes, whoa, what happened? How many times are you waiting for embedded Jetty or whatever to start? This thing just runs. So that was kind of my first impression of the language, just mind-blowing. Is yes, you get this benefit. You don't have like a compiler that's doing things for you. So you're free to kind of, you get this very rapid development thing where you can just write tests and execute them, and you don't have to start environments. Everything kind of is immutable. There's no shared state. And so you develop in a REPL. All of these things, you can run them individually in a REPL. Now, one of the powers that Clojure gives you is this idea that it was designed for concurrency, and this is a blah, blah, blah. But the idea is that everything in Clojure is immutable. And because of that, you don't have problems that you normally have in other languages with concurrency. There's no locking. There's nothing that you can do. What you do in order to kind of deal with threads and deal with concurrency is you have these primitives in the system. I'm not going to go into details, but the idea is that those two allow you to, like this, vars are like thread local, they're bound to a thread, and they're like a thread local values that are invisible to other threads. And refs allow you to share synchronously data between those threads in a transactional way. So yes, you can see this. So Clojure has this notion of STM, of software transactional memory. I'm glossing I'm glossing over a lot of details right now, but this idea is that you can update things concurrently using transactions. So either all changes succeed or they don't succeed at all. And it's done without locks. And it's done with automatic retries, like a database transaction. You can retry those things automatically. And you can have either synchronous changes, or you have agents, which is sharing asynchronous changes, like sending messages. So you have an actor system built in the language. And so this makes Clojure suitable for highly concurrent system for like processing data, lots of data. It can be unstructured, it can be streaming JSON. Yes?
I remember talking to Shlomo about the Clojure, and
yeah.
Okay, so if you need state, it goes to the database. And then you're very dependent on this architecture.
Yeah.
It's fast. So you move the power from one place to another.
And that's possible. So I have to say a disclaimer, like I don't know any of these languages, not really, but I know what they do. So you might. So the question was like for the recording, the argument was that you kind of move, if you need state, you move this to a database, you offload it. That might be true. That might be the pattern that is used in this language. I really don't know, unfortunately. But I would find out, because if that's something that I had to deal with, now I know where to look, okay? Whereas previously I just wouldn't care. So something that's highly concurrent and allows me to process like data, like JSON, like streaming data, like video data. So you can use this, and it's fully interoperable with JVM. So that's just one example of a language that solves the problem of concurrency really well, and it's dynamic, it's fast, and everything. The other thing is Erlang. Again, this is just my series of discoveries over the last few months. This is just the things I learned about in the last couple of months. I knew they existed, but I didn't care about them. Now I do. So Erlang is this language that was created in the 80s by these gentlemen, and this guy's wearing his socks and sandals. I don't know, and he's supposedly, I don't know, Danish or something. So it was created in Ericsson, the telecom company, to handle telecom communication, to handle phone calls. So millions and millions and millions of phone calls, and it had to be done in a way that is fault tolerant and distributed and never fails, because you cannot drop phone calls. And the system allows you to patch it while it's running, so you can do dynamic hot swaps. Apparently, that's amazing. But it also is reported to have achieved 9 nines of reliability. So there was some study by British Telecom on some piece of equipment they did. 9 nines means about 5 minutes of downtime per year. I don't know, Mr. Reliability expert will tell you. So some people claim that 5 nines is hard, 7 nines is almost impossible. They did 9 nines. I'm not sure, maybe it was in a controlled environment or not, but that sounds insane to me, like a system that just is never down. So it's used in the industry, it's used by WhatsApp to handle all the 20 billion texts every day and images. And it's used by Amazon, ActiveMQ is written in it, most telecoms are using it. And the language itself, Erlang, is a bit old, so there are more modern languages on top of the VM. Most prominent one is Elixir. It looks like a Ruby, but it runs on top of Erlang VM. And so the idea behind Erlang is this message-driven style, which is basically the actor model. So what does it mean? What you have in Erlang, in the system, is you have this idea of a lightweight process. Now, this is not a process that runs in like an operating system process. This is a small, very thin unit of computation that has its own mailbox, a system that can just receive messages. It has the actual computation, the actual code that's running, and it manages its own state. So whenever a message arrives asynchronously, all right, it is put in the mailbox, and then it's retrieved and then synchronously processed. So sort of like, you know, sort of like if you're familiar with actor models, this is how they work. So everything here is kind of like single-threaded and very light and very small. But the idea is that in a single system, you have tens of thousands of these. Okay, so you can spin up tens of thousands of these little processes, and the idea behind Erlang is the philosophy is if you have an error, then you just let it die. You let it crash and burn. If you get a message that somehow is resulted in this being an error, this process dies and it is immediately replaced by another one. Okay, and it is all handled by the system called the supervisor and the observer, which is controls. And this is a tool that you get, like Erlang VM comes with this tool that shows you all kinds of information about the system, like loads and number of processes, and you can manage things. And the point is, it blows my mind that Erlang had this 30 years ago. 30 years ago, they invented this, and we are now kind of rediscovering this with Akka and other messages, and so and other system like this. So it's kind of amazing to me that just this cycle continues. We keep rediscovering things that were invented, like Lisp. It was written in '58, like 60 years ago, and it had all the features of all the programming languages that exist today. It had that 60 years ago. So one more that I wanted to show you is Elm. Now, Elm is a programming language for creating web apps, which is typed and functional, and it is designed for people who are not front-end developers. So you don't have to know anything about JavaScript, almost anything about JavaScript. It ends up compiling to JavaScript. That's like an implementation detail. Once WebAssembly is a thing, it will. Yes.
Just for front-end development, just for writing in the browser.
As far as I see, a browser and UI. There are some frameworks that because that's a good question. The question is whether or not it's just for browsers. It works invents this system called model view update, where your model is immutable. And if you want to change it, you change the model and you update, and you call the update function, and it will just update your view with the updated model. So you have to present something, I guess. But I really don't know. Again, as far as I know, you can run it on the server. Yeah.
So there's pure script, which is syntactically really
Right. Yeah, so the comment was that yes, you can run it on the server, but it's a bit hacky. So it's like Node.js. All right, I see. The idea here is that this model view updates, safe updates, and the thing that amazed me about this is this thing that said designed for usability and developer happiness. Now, what does that mean? So let me show you, like, this is the only code sample that I want to show you. Like, this is, like, you go to the site, you have these examples. This is what a program looks like. Again, try to look beyond the syntax. You have an entry point that defines an initial model, which is the number 0. So the application is like 2 buttons that increase and decrease some value, right? So you start with the model being 0, and view is the view function, this one, that tells how to render the view. And the update is the update function, which handles the update events, sort of. But the idea is that everything that you see here is kind of like an immutable model. And it's declarative. It's very declarative style. It describes what's going to happen, and when actually it runs, things will actually get rendered. So nothing that's not declared here explicitly will happen. So you have sanity in that regard, as opposed to things happening in JavaScript. There's no such thing as undefined is not a function in this model, because there's no such thing as undefined, right? So what this does is yeah, there's a model that draws like a button, a div that shows the toString of the model, and the onClick will send these two values, which is just like a type alias, which just a type. Like a case class in Scala, which says increment and decrement, and this is the update is just like a pattern matching. So in case of an increment, you just increment the model and you return it, and the decrement, you decrement the model and you return it. It ends up going to the beginning, and the model gets rendered. So this is how it works. The point is that if you make a mistake, all right, so you can type just this. If you try to do this and you try to compile, the compiler will not scream at you, but the compiler will tell you what went wrong, and it will tell you how to fix it. It will tell you that I need HTML, SVG, or a program, whatever a program is, I don't really know. So I have something to render, but you gave me a string. So please fix it. It tells you, it doesn't only tells you what went wrong, what the type error is, it tells you how to fix it. And it's a common recurring theme. The designers of the language said, we don't want, like if the error doesn't tell you how to fix it, it shouldn't be an error. It shouldn't be in the language. And so, for example, if you try, this was one common case, if you try to combine 2 strings together with a plus, you have to use 2 pluses in Elm for reasons. And it says the left argument of plus is causing a type mismatch, blah, blah, blah. Hint, to append strings in Elm, you need to use the, so it helps you. So it helps you out. It keeps you sane. And one last thing, which is, well, almost last thing, which was amazing. So if you make a typo, whereas in JavaScript you would run and crash in runtime, here if you make a typo, it will tell you maybe you meant one of these. It tries to look in the scope and try to syntactically find matching values or matching things. So it guides you. So the compiler there, it's a statically typed language. It's a functional language, but for the web, but the compiler is not in your way. It actually guides you towards doing the right thing. And finally, what amazed me in Elm is it comes with its own package management system. And so you can publish your package to the Elm repository. And it will enforce semantic versioning on you. Which means that if you change the API in such a way that it breaks, it will not let you publish. It will say, you were trying to publish a minor version, but it looks like you changed the API, so you should bump the version. Elm would rather you work a little bit harder as a developer, but you don't break your users. Imagine we had this in our day-to-day, like every minor version upgrade would be really enforced by semantic versioning. Or a snapshot. That's just mind-blowing. And this is the kind of thing that you can do, which is based on like, I don't really know how to explain it. Finally, there's Scala. Now Scala is interesting because it's this kind of also a multi-paradigm language. The point is about Scala is that it's built, what makes it special is that it's multi-paradigm, but in a good way. It's a way that gives you equal kind of, I used hints here to kind of describe it better. Whatever. It treats both paradigm, the object-oriented and the functional paradigms, more or less equally. So you can use it as kind of a Java, or you can use it as kind of Haskell. So it doesn't really support maybe some functional things, but your main paradigm is this object-oriented. It lets you decide. So some people call jokingly Scala, they call it the Hascallator, because it's like a scale. You can use it in any way that you want. And this is all not really a coincidence, because Scala is kind of built in this way where it stands on the shoulders of giants. So this is the team that implemented Java generics. This is Phil Wadler, who is a professor of computer science and one of the people responsible for Haskell. He is the main designer and dreamer, creator of Haskell. This guy you know. This is Gilad Bracha, which is also one of the main chief architects in Oracle or Sun or whatever, one of the main Java guys, and I don't know who that other guy is. But like any successful 90s boy band, the prettiest one goes and has a solo career. And when he went off and built Scala, he did this in a way that he borrowed a lot of ideas from all of these other languages that were out there, from Lisp and Haskell and Erlang and Java and C# and everything was put into the language. But arguably, I would argue that he actually did a good job, because it's impossible. The biggest problem with multi-paradigm languages is just it doesn't really do one thing well. It has to compromise on a lot of things in order to satisfy everybody. And Scala also, of course, compromises a lot on it probably won't compromise on type safety, but this has other trades-offs like compilation time and stuff like that we experience every day. So I'm done. If there's one takeaway that I want you to have from this talk is that I couldn't find a better screenshot. This is from Fight Club. That we as developers, that we are not our programming language. That we shouldn't be about wars and tabs versus spaces or I don't know, dynamic versus static or object-oriented versus functional or I don't know, Emacs or Vim. We need to, why not both? Why limit ourselves to just one? Why not embrace this world of solution that is out there and really use the right tool for the job? And this Peter Van Roy guy, at the conclusion of his paper on paradigms, said there's certainly not true that there is one best paradigm. There just isn't. The best paradigm is a multiple is a collection of many. So I guess what I was trying to say is that revolution will happen. We have this functional programming revolution for the last 15 years, ever since Intel decided that it will not do single core processors anymore. So the race began to kind of to be concurrent and to be massively parallel, and that required changes in languages, that required thinking about immutability differently, and almost like there's no programming language today that doesn't incorporate at least some of the functional paradigms, because functional paradigms solved this problem years ago, before there were even multi-core systems. I don't know how or why, but it just happened. And so unless I'm crazy, and that's not really what's going on, so I think there's this revolution that's happening again. We need to be not to deny that it exists. We need to be in the center of it. So we need to learn from the past, kind of. If somebody mentions Lisp, so maybe not dismiss it as like archaic nonsense, and go and study that, see some ideas from that. And we should celebrate that we're in this unique field and unique opportunity that we can enjoy kind of this diversity of languages and tools and ideas, and just embrace them. And that's it. Thank you very much for your time. Yes.
So you showed earlier the cycle of
Yeah.
revolution.
Yes.
So where do you think, currently, language paradigms, where are we at in the cycle?
That's a good question. So the question was with regards to this. Let's try to go back and see. blah, 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 blah. This thing, the cycle. So the question was, with regards to programming paradigms, maybe, where are we at the moment? What I think personally is that, like I said, it requires some anomaly to create a crisis, and crisis drives ideas and drives this new acceptance. So I think we're somewhere here, possibly towards the end, because I think that the crisis was introduced in the early 2000s, the most recent one, the early 2000s with the introduction of multi-core systems, where the free lunch was over, we needed to be immutable, we needed to do all of these things that previously were just hard, moving from shared state to other kinds of things. And whether or not it will become ubiquitous or like more common, I really don't know. I wish I did. I really want to, because my paradigm shifted, and I truly think that maybe it's not like the ultimate solution for everything, but it's definitely a better, like, I think it might be a slightly better idea than what we're doing now, or like we as in general. Like, I think maybe not a very popular opinion, but I think OO has reached, like object-oriented has reached its maximum potential, and it just doesn't scale anymore beyond that. So we are doing the best we can, managing all of this complexity, and we just have to, I don't know, look somewhere else. I really don't know. That's just my opinion. Anything else? Yes?
If you look at the industry, not even in the model drift, like maybe in the academy or somewhere close to the model pricing, there are a lot of researchers that are researching software transactional memory and all these other models.
Yeah.
I don't think it's even in the model.
So you don't think we're in the model drift? I tend to maybe not entirely agree with that, because I think, like, and again, I come back to this example of Haskell. I went and did a course on Haskell because, you know, suddenly realized that I like it. And I noticed that a whole incredible amount of features that we have in today's languages come directly from Haskell. And it had like 40 years of academic research ahead of its time. Like, people in the academia were researching the way as far as I understand, the first versions of Haskell didn't even have the ability to handle I/O. They didn't need it. They just input some numbers and they produced some output. They didn't know how to handle I/O. And this came later. This ability to make it more like general, well, not general purpose, but more approachable to others. So I think, yes, academics are busy of doing that, but you have people like Rich Hickey and the guys behind Elm bringing to life some ideas that, you know, that they existed probably for years, but they're just implementing them. And again, I don't have a good answer. So I think we know that there's a problem, but maybe we don't know, like, where the most compelling idea will come from, whether from academia or from the industry. The industry doesn't seem to be innovating, I think. Not as much as probably we would like. I don't know. So anyway, I think it's enough. I took your time. Thank you very much.